We are going to dive into a hypothetical scenario that has been on everyone's minds for decades. What would happen if scientists found an asteroid heading towards Earth? To illustrate the necessity of planetary defense, scientists have described what would occur if an asteroid were to collide with Earth. The fictitious asteroid scenario shows the potential destruction such an impact could wreak, as well as how an asteroid threat might develop over several years. The experiment was presented by a group under the direction of Paul Chodas, manager of NASA's Near-Earth Object (NEO) program office, on April 4 at the 8th Planetary Defense Conference in Vienna, Austria. Chodas's fictitious scenario begins on January 10, 2023, with the finding of a brand new asteroid given the designation 2023 PDC. The object is initially classified as a potentially hazardous asteroid, PHA, as defined by NASA. Any asteroid that intersects Earth's orbit at a distance from the planet of about 4.6 million miles, 7.4 million kilometers, or less, and that had a magnitude of 22.0 when discovered, which is only slightly brighter than the faintest stars visible to the Hubble Space Telescope. Chodas noted that while the asteroid tracking equipment on Earth continue to watch the rock, better restricting its orbit around the Sun, the impact probability of 2023 PDC first rises to just 1 in 10,000. On April 3, 2023, Chodas designates a time period as Epoch 1, at which point the scenario becomes severe. Epoch 1 began today, and the impact probability has increased to 1%, according to Chodas. The potential impact won't happen for another 13 years, so it isn't urgent, but we can already estimate when it might. The NEO program manager emphasizes that crucial decisions need to be made now, despite the potential effect date being estimated to be October 22, 2036, which gives more than a decade for preparedness. The way mankind responds to the threat will depend on a number of unresolved issues, some of which are characteristics of the 2023 PDC asteroid itself. Estimating the scope of the 2023 PDC asteroid problem. Improved measurements of the asteroid's size will be one of the first things astronomers perform with their 13-year lead time. According to NASA, opens in new tab. This is accomplished by calculating the asteroid's albedo, or how much light it reflects back into space. Hence, in theory, the larger the asteroid is, the more light it reflects. The issue with this measurement is that the albedo primarily depends on how reflective the surface of the asteroid is. Hence, a small, light-colored asteroid may have a higher albedo than a huge, dark-colored one. As a result, the size of asteroids may be subject to considerable uncertainty. The size of 2023 PDC is estimated to be between 720 and 2,200 feet, 220 to 660 meters. However, if the asteroid's surface is black, it might be as wide as 1.3 miles, 2 kilometers. The size of the asteroid is crucial since it will decide not only how much damage it causes, but also what steps must be made to divert it, or even whether this is even possible. According to Chodas, nuclear is truly a key approach on the table when you have a gigantic item, even as large as 2 kilometers, 1.2 miles, and there's a very, very little possibility of that. Hence, a kinetic impactor would be necessary for a huge asteroid to strike Earth. Such a diversion, such as that recently proven by NASA's Double Asteroid Redirection Test, DART. According to Chodas, 2023 PDC is too close to the Sun for infrared astronomy to be used to estimate its size, since the Sun's intense light would wash out the light from the object. Hence, infrared-focused space-based observatories like the James Webb Space Telescope, JWST, and the Hubble Space Telescope won't be of much use in observing this rock. Similarly, the asteroid will be too far away early in its approach for radar to detect it. Chodas says that implies our initial options for measuring the asteroid's size are optical observations only. This restricts the amount of information astronomers may gather about 2023 PDC, information that could more precisely define the asteroid's size and orbit. During the 13-year lead period, decision-makers will have the option of sending a reconnaissance spacecraft to 2023 PDC. This would not only improve our understanding of the asteroid's size and mass, but it would also help us better constrain another critical component of the asteroid that is essential to reducing its impact on Earth, its orbit. 2023 PDC is too far away from Earth to accurately determine its orbit at the time of its detection in this hypothetical scenario, because it is about 124 million miles, 200 million kilometers, away. The asteroid will likely catch up to Earth over the next 13 years, and the two could collide in a small red box that represents the intersection of Earth's orbit and the 2023 PDC, according to Chodas. It's distant and faint, but it has a very similar orbital period to Earth, in fact, is slightly shorter, which means the asteroid will slowly catch up to Earth, he said. Where the asteroid will be in 13 years is a subject of considerable uncertainty. That uncertainty will decrease as we keep track of the asteroid until it really gets smaller than Earth. The red hitbox in the team's calculation was shrunk to a size smaller than the size of the Earth, indicating that the 2023 PDC will impact the globe. Astronomers can then start making precise predictions about what location on Earth the asteroid will collide with the Earth. So, what harm is done? Lorian Wheeler, a NASA advanced supercomputing expert, described how assessing the possible harm from the 2023 PDC entails developing an asteroid impact risk assessment model and taking into account a variety of variables, such as asteroid size and other features, from sparse observational data. We model three basic categories of impact dangers. They include nearby ground damage brought on by a fireball or explosive detonation, according to Wheeler. Moreover, tsunamis have the potential to have significant oceanic consequences, and in the worst situations, they may have an impact on the global climate. We model all of these situations, aggregate the results, and look at the probability of different damage amounts and harm severities, how many people that damage may potentially affect, and what regions could possibly be at risk. The lower size estimate for the 2023 PDC is roughly 1,000 feet, 300 meters, in diameter, which would cause destruction on the scale of an entire continent and emit up to 2,000 megatons of energy. That is equal to 133,000 times the energy that is thought to have been released by the bomb that destroyed Hiroshima at the end of World War II. The possible catastrophe that 2023 PDC's influence could cause becomes considerably as its size increases. With a diameter of 2,000 feet, 600 meters, the impact would be on the verge of a global catastrophe. This massive hit from 2023 PDC would produce up to 20,000 megatons of energy. Hence, doubling in size has resulted in an increase in destruction power of about 10 times. The 2023 PDC impact scenario gets extremely bleak at 3,330 feet, 1 kilometer, wide. The team determines that 2023 PDC is considerably more likely to result in a global catastrophe at this size. Around 100,000 megatons of energy, or 6.6 million Hiroshima nuclear explosions, would be released in such an impact. According to Wheeler, there are other elements besides size that affect the spectrum of possible impact energy and, consequently, the severity of the subsequent damage. One such aspect is the asteroid's angle of entry into the atmosphere. Wheeler continued, the most likely danger will be a big ground impact or low airburst producing an extremely devastating blast wave and fireball. The damage severity is anticipated to reach unsurvivable levels given the size of the objects we have on hand, with larger regions of damage spreading to other places and causing structure damage, fires, and broken windows. According to Wheeler, for smaller impacts, the peripheral damage areas are a band that may have a diameter of between 62 miles and 124 miles, 100 to 200 kilometers, away from the main impact zone. In circumstances where the hypothetical asteroid approaches sizes, this expanded damage zone might have a diameter of up to 372 miles, 600 kilometers, and 2,000 feet, 600 meters. According to Wheeler, a large number of individuals, typically in the range of hundreds of thousands to millions of people, could be harmed all along the swath. The population damage from impacts over land is between 10,000 and 10 million persons, depending on the region. And if the impact is on a broader scale, those ranges could reach the tens to the hundreds of millions of person range. The asteroid 2023 PDC would cause a tsunami if it were to impact any ocean, she added, but it would cause the most harm to people if it were to strike the Atlantic Ocean since it would be the most likely to cause a tsunami that may affect populated regions. A greater 2023 PDC asteroid collision could potentially have climate change consequences that could eventually have an impact on millions to billions of people worldwide. The conclusion, said Wheeler, is that there is a very wide spectrum of potential injury. Given the various outcomes, if it impacts Earth, it might be quite catastrophic. How concerned ought we to be? It is crucial to emphasize that 2023 PDC is an entirely fictitious object and is not headed toward Earth. In actuality, no sizable asteroids are expected to strike Earth in the next 100 years. The 1,100 feet 340 meters diameter asteroid 99,942 Apophis, which was expected to come perilously close to Earth in 2068, had the highest chance of crashing into the planet. But NASA disregarded this possibility in 2021, and 99,942 Apophis will now pass the Earth without harming it. But however, that doesn't rule out the possibility of an object with an orbit that crosses Earth's route around the Sun that is just waiting to be found. The scenario Shondas and Wheeler outlined for 2023 PDC, however, is rather extreme. In fact, Rolf Denzing, Director of Operations for the European Space Agency, ESA, commended the scientists for coming up with a thought-provoking scenario that would play out spectacularly. The researchers presented the likelihood of Earth being bombarded by objects from space of various sizes, arguing that impacts involving larger bodies should be rarer, in order to determine how feasible such a situation is. While asteroids with a diameter of around 2,000 feet, 600 meters, are anticipated to strike the Earth roughly once per 200,000 years, those with a diameter of about 1,000 feet, 300 meters, typically cause collisions every 70,000 to 70,000 years. Around once every 700,000 years, asteroids with a diameter of 3,300 feet, 1 kilometer, or greater are predicted to strike the Earth. A 3-mile, 5-kilometer diameter asteroid, which is much more massive, is anticipated to hit Earth only about once every 30 million years. That's all for today's video. Thanks for watching, and remember to keep looking up at the stars. Who knows what we'll discover next?